We are on problem number 12. Problem 12. What is the greatest of five consecutive integers if the sum of these integers is 185? So what is the greatest? So let's assume x is the greatest. And they're consecutive integers. So what's the second to greatest? Well, that would be x minus 1. The third to greatest would be x minus 2, x minus 3, and x minus 4, right? These are five consecutive integers where x is the largest, right? Right? If if x was 150, x minus 4 would be, these numbers would be 150, 149, 148, 147, 146, like that, right? So these are consecutive integers. X is the largest. And they're telling us that the sum is 185. So the sum is equal to 185. So what is this sum? How do we sum these up? So we have 5x's, right? So we get 5x. And then what's minus 1, minus 2, minus 3, minus 4? So 1 plus 2 is 3. 3 plus 3 is, this is where I always mess up. 3 plus 3 is 6. 6 plus 4 is 10. Right? So you get 5x minus 10 is equal to 185. Add 10 to both sides. 5x is equal to 195. And you could eyeball this. You could say, well, how many times does 5 go into, you could say, how many times does 5 go into 200? And it's going to be 1 less than that, right? 5 goes into 200. What? It goes into it 40 times. It'll be 39. Or you could divide. 39. If you didn't want to do it that way, you could say 5 goes into 195. 3 times 5 is 15. 45, 39. So that's our answer. X is 39. It's the largest of the consecutive numbers. So those numbers are 39, 38, 30, 37, 36, 35. Those are our five consecutive numbers. Next problem. Problem 13. A salesman's monthly gross pay consists of $1,200 plus 20% of the dollar amount of his sales. So plus 20% of the sales. S, I'll say for sales. If his gross pay for 1 month was $2,500, so in this month his gross pay was $2,500, what was the dollar amount of his sales for that month? Well, when I read it, I essentially set up this equation, right? His compensation is $1,200 plus 20% of his sales, and we know that that equals $2,500 in this month. So let's subtract $1,200 from both sides. So you get 0.2 S is equal to, what's this, 1,300, right? And so S is equal to 1,300 divided by 0.2. And the way I like to think about this, 0.2, instead of having to do this decimal, which you could do, is I could have rewritten this. 20% is the same thing as 1/5, right? So it's also 1/5 S is equal to 1,300. And now this is easy. Multiply both sides by 5. So you get S is equal to 1,300 times 5, which equals what? 13 times 5 is 65. And add the two zeros. So S is equal to $6,500. That's the monthly sales that month. I was a little redundant with the word monthly just now. Next problem. Problem 14. Okay, so they've drawn a circle. And then let's see, they've told us that this is let's see. They tell us that this is 40 degrees. Tell us that this is 40 degrees. And what they want to know, let's see. Naomi makes silver jewelry. For one style of earring, she cuts wedges from a silver disc, which I guess is depicted here, as shown in the figure above. Each wedge makes a 40-degree angle at the center of the disc. If the weight of each uncut disc is a uniformly distributed 2.5 grams, 2.5 grams. That's how much this whole silver disc, I should have done it in gray instead of magenta because it's silver, but anyway, it's 2.5 grams. How many grams does each wedge weigh? So we essentially just have to figure out what fraction of the entire circle is each wedge. Well, each wedge is 40 degrees of a pot. How many degrees are in the entire circle? Hopefully it's second nature to you by now, but there's 360 degrees in the entire circle, right? So the wedge is what fraction of the entire circle? Well, each wedge is 40 over 360th 40 over 360 of the entire circle. And that's what? That's equal 1/9. Divide the top and the bottom by 40. Right? 4 goes into 36, right? 9 times. So each wedge is 1/9 of the entire circle. I just did that based on the fact that it's 40 degrees over 360 degrees. So if each wedge is 1/9 of the entire silver piece, and the silver piece weighs 2.5 grams, then each wedge will weigh, so a wedge will weigh 1/9 times 2.5 grams. Right? And if we want to write 2.5 as a fraction, how do we do that? That might be convenient right now. Well, I'll tell you, that's the same thing. Now you could multiply it out, and that's all fine. But you could also recognize that 2.5 can also be written as 9 over 4. Oh, no, it can't. Sorry. 2.5 could be written as 5 over 4. No, as I'm pathetic. 2.5 can be written as 10 over 4. Right? Because 4 goes into 10 two times. Why am I even writing 10 over 4? See, my brain is malfunctioning. 2.5 can be written as 5 over 2, which is 10 over 4. But I was somehow thinking of number 9, and I'm not going to make excuses for my deficits. Anyway, so what's 1/9 times 5/2? It's 5/18. So each wedge is going to weigh 5/18 of a gram. The other option is you could have divided 2.5 by 9, and you would have gotten another answer with decimals. Either one would have worked because these are free answer questions. Next problem. Or can you actually use a calculator on the SAT these days? If you can, then that would have been an option as well. Problem 15. If x squared minus y squared is equal to 10, and x plus y is equal to 5, what is x minus y? Before I even read the rest of the question, when I saw this, it should be like your knee-jerk reaction when you take the SAT. When you see x squared minus y squared equals 10, you should say, well, that's the same thing as x plus y times x minus y is equal to 10. You just factor this difference of squares immediately. You almost can do that before you read the rest of the question. And they tell us, what's x plus y? X plus y is 5. So 5 times x minus y is equal to 10. Divide both sides by 5, you get x minus y is equal to 2. That's it. Next problem. So they draw us, let me invert colors. So they draw us a rectangle. And then within that rectangle, there is another rectangle, where it looks like this. Another square, really. And what I've drawn doesn't look that much like a square, but it's close enough, I think. You get the idea. And this is obviously right angle, right angle, right angle, right angle. They tell us that this distance is 2. This distance is 3. In the figure above, what is the area of the shaded square? So this is a bit of a trick. And actually, let me do it in the next video so I can kind of delve deeper into the trick. I'll see you in the next video.